All right, so welcome back. Today in this video, we're going to be looking at some fluid mechanics practice problems for the Civil FE exam review. And for the first section that we'll be covering in fluid mechanics is going to be flow measurement. So let's go ahead, dive into the practice problems. Some important things to note as you're doing these type of practice problems is units are very key and they can be very tedious. So as we're going through, you'll notice I'll be making sure our units make sense, canceling certain units off, and making sure we get the proper unit so that we can get the right answer that we need. All right. So number 1 says, what is the specific gravity of a fluid that has a density of 1,000 kilograms per meter cubed and a specific weight of 9.81 kilonewtons per meter cubed? Okay, so what information are we given? We're given the density of the fluid. We're also given the specific weight of the fluid. Okay, what are we trying to find? We're trying to find the specific gravity of the fluid. Okay. All right, so what formulas do we need? Well, I'm going to do a quick search in the manual and see what comes up for a specific gravity. So 13 different things come up. So I first come into the fluid mechanics section. That's a good sign because that's what we're currently doing. All right, so it says SG is equal to the density or the unit weight over the unit weight of water, which is equal to the density over the density of water. Okay, so if we know that we're going to be using this formula, because I feel like this is it's a good place to start. We have so we'll just say SG is equal to density over density of water. So we have the density of the fluid, and I'll just say fluid. What is the density of water? Well, it gives us the density of water here, 1,000 kilograms per meter cubed. All right, so this is going to equal the density of the fluid is 1,000 kilograms per meter cubed all over the we have the density of water, which in this case is the same. This is not always the case. All right, and what do we get? Well, everything just cancels out to equal 1. So our answer is B. We could have done the same thing using the specific weight. Ironically, the specific weight, it was the same for water, so either way it would have canceled out if you wanted to use this particular version of the equation. I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course.
and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post.
All right, so welcome back to the fluid mechanics section of the Civil FE exam review. Today we're going to be looking at fluid properties, and so I have a few practice problems for y'all to go through. And so again, units are going to be key for us, and so let's go ahead and dive right in. So number one says a fluid has a density of 1,000 kilograms per meter cubed and a dynamic viscosity of 0.1 Newton seconds over meter squared. What is the kinematic viscosity of the fluid? Okay. So what information are we given? Given the density. We're also, and the dynamic viscosity. I'm just gonna abbreviate. Okay. What are we trying to find? Well, we're trying to find kinematic viscosity. Okay, so what formulas do we need? Well, I don't know by heart the formula for kinematic viscosity, but I know that's what I'm trying to find. So I'm just going to do a quick search. All right, so I do a search for kinematic viscosity. All right, here's what comes up. Kinematic viscosity is the symbol kind of V. So V is equal to, okay, let's make sure we have some other variables that we'll need. What is this mu? Well, the handbook is going to tell us what this top mu is. So mu is the absolute dynamic viscosity of the fluid. So we have mu. So this is mu. All right, and then it's all over density. And we know that from this formula, density of the fluid is the P. It tells us in the handbook. Okay. So this is our P. Okay, so now it's just a matter of making sure our units make sense and going from there. So we have our dynamic viscosity, right? But if I take, I'm just doing kind of like a, let's just write it out for simplicity terms. So if I have a point, this equals 0.1 Newton times seconds over meters squared, all divided by, so that was our mu, all divided by our density, which is 1,000 kg per meter cubed. Okay, so what's the problem here? The problem is our units don't cancel out. All right, so we have kilograms over meters cubed. So meters. Okay, we got this Newton seconds going on. So is there a conversion that we can make with newtons to get this thing to be in kilograms or something to cancel out more units? All right, so I'm gonna look up what Newton equals in the unit conversion section, because I'm sure that there is a conversion for this. All right, so I just jump to the conversion section. And we learn that 1 Newton is equal to 1 kg times our meters over second squared. So 1 Newton is equal to 1 kg times m over s squared. All right, how does that help us out here? All right. Well, it helps us cancel out more units. So once we convert this again, right, we have 0.1, and now I'm substituting my newtons, all right? This is what I'm substituting out. It's newtons. Okay. For this. So 0.1 times 1 kg m over s squared. Okay. Now, going back to my other unit, times s all over meters squared, and then that's all over 1000 kg over m cubed. All right, so our units, they're going to simplify to equal 0.0001 meters squared over seconds. So our kilograms will cancel. This unit just cancels to a s, right? And then we're left with this meters cubed is going to be multiplied by meters, so it's going to be meters to the fourth over meters squared. It's going to give us our meters squared over a second. So that's how our units are going to cancel. So we are left with A. So just making sure you understand your units, making sure you understand what variables they give you, and then just writing it out, listing out everything, and don't worry about, how confusing sometimes the units get. Just take your time as you're practicing. And so this stuff will come much faster to you once you actually have done multiple problems of this. So All right.
I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post.
All right, so welcome back to the fluid mechanics section of the Civil FE exam review. In this video, we're going to be going through fluid statics. And so I have a few practice problems for you all. So let's go ahead and dive in. All right, so number 1 says, calculate the pressure at a depth of 10 meters in a fluid with a density of 1,000 kilograms per meter cubed. Neglect atmospheric pressure. All right, so what is the information that we're given? We are given the depth, which is 10 meters. We're also given the density. That's the symbol P. But the density is 1,000 kilogram per meter cubed. All right. And it says neglect atmospheric pressure, or AP. All right, so what are we trying to find? The pressure at the point in the fluid. At the point with depth of 10 meters, right? All right, so let's say you have, what does this visually look like, right? So now I've been using blue a little bit, but really, so you have water or a fluid in this cup, and I will, let's erase that. Hope that you like my drawings, by the way. So let's say our fluid is in a cup, right? This is our cup. The top, right? And we are trying to find the pressure at this point. Here is the distance from here to here is 10 meters, right? We just want to find the pressure with that depth of 10 meters. And we know the density of this fluid is 1,000 kilograms per meter cubed. All right. So now let's look at how we get this. So I don't know I don't know the formula, or the formula that I need for a pressure, but what I can do is I will get in the fluid mechanics section of this and see if I can start looking at pressures. specifically of a submerged. Okay, so here it's like forces on a. Okay, so the pressure on a point at a vertical distance h is what we have. Below the surface is P is equal to, what does P stand for? P is pressure. P atmospheric, or PATM is atmospheric pressure, which we're neglecting. The rho is a density. That's the symbol for density. G is gravity. And then H is the distance, that vertical distance. Okay, so let's solve, all right? We have, I believe, everything that we need. So P is equal to PATM plus rho GH. All right. So we're neglecting atmospheric pressure, so that just goes away. And we are left with P is equal to, what is my rho? Well, 1,000 kilograms per meter cubed. Rho is just the density, times the gravity, which gravity in a fluid is, gravity in general is 9.81 meters per second squared. And then what's our height? Our height is 10, our depth, which is h, 10 meters. All right. Now, once we get our units, we get, or once we cancel our units, we get 98100 kilograms over meters per second squared. Okay, or A.
I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post.
All right, so welcome back to the last section of the fluid mechanics portion of the Civil FE exam review. Today, we're going to be looking at energy, impulse, and momentum of fluids. So I got some interactive problems for today that aren't super complicated, but let's go ahead and get into them. So number one says, the density of air flowing in a duct is 1.15 kilogram per meter cubed. A Pitot tube is placed in the duct as shown. The static pressure in the duct is measured in a wall tap and pressure gauge. Use the gauge readings to determine the velocity of the air. All right. So what are we given, right? Well, we're given the density of air, we are also, what else are we given? We're given pressure readings. Of the static pressure coming in and out. Right. Okay. So we're also given that this is a Pitot tube. Right. What are we trying to find? Right. We're trying to find the velocity of the air. So, velocity. Okay. Are there any formulas that we need? Well, first and foremost, let's also get these readings. For those of you who it's kind of hard to see, it's like it's coming in at 6 times 10 to the third pascals. And it's going out at 7 times 10 to the third pascals. Okay. So those are our readings coming in and coming out. All right, so let's start by just searching Pitot tube because I don't see if we can find a formula that we can use. So I do a search. All right, Pitot tubes. Okay, so V is the velocity of the fluid. Well, in this case, it's going to be air, but the stagnation pressure and the static pressure. So of the fluid at the elevation where the measurement is taken. So PS is the start, and P0 is where it ends. All right, so it ends. So this would be our P0, and the static pressure, the fluid at the where the measurement is taken, is here. So that's going to be our PS. Okay. And what else is in this formula? So we get the velocity of the fluid. So V is equal to square root 2 over the density. That's what rho stands for. Times P0 minus PS. Now, do we know what rho is? Yes, we know the density of the air, right? This is rho. All right, so we have rho, we have P0, and we have PS. Now it's just time to solve, right? All right. So when I solve this, I get square root of 2 over 1.15 kg per m cubed. Okay, and then 7 times 10 to the third PA minus 6 times 10 to the third PA. Okay. So we have to know that our units don't match. So once we bring this over, we get, and I'll just bring this up here. It's going to transfer everything that we're doing up here. So I get 2. Square root of 2 over 1.15 kg m to the third times 1,000 pascals. All right. How do we get pascals to go into kilograms, or get some units to cancel, right? All right, so let's go to our unit conversions section to see if that'll help us. All right, so 1 Pascal equals 1 Newton per meter squared. So we'll start there. So 1 Pascal is equal to what is it? Newton over meter squared. So 1 Newton over meter squared. Okay. So I'll be able to switch that unit into Newton over meter squared, but that's still not going to cancel out my units completely. So is there anything, can I get this Newton? What is a Newton? So 1 Newton, and we'll change the color. So 1, can we get that in kilograms or something so that units can start canceling? So 1 Newton is equal to 1 kilogram times meters over second squared. One kg m over second squared. Okay, so now let's take this and substitute it into our newtons. All right. So now 1 Pascal. So 1 PA is equal to 1 is equal to 1 kg times m over s squared. And then all of that over meters squared. And so that simplifies to it just being kg over m dot s squared. Okay, so 1 kPa equals 1 kg over meters times second squared. All right, cool. Now that we have all of that, now we know that we can substitute these units into here. We just want units. We just want units that will make sure that things cancel. All right. All right. So let's do some erasing. Hopefully you wrote this stuff down. All right. So the last step would just be us, again, substituting the values that we need. And this is all for velocity, right? So get velocity is equal to square root 2 over 1.15 kilogram per meter cubed times 1,000. Instead of PA, we're going to put kg over m times s squared. All right. And all of this is going to unit wise is going to be should be meters to the these are going to cancel, right? So we're going to get our answer in a meter squared over, our units are going to be meters squared over second squared. We're going to take the square root of that, and it's going to give us our meters over seconds. And so the answer is going to be 41.7 meters per second. So units are the main thing here. We want to make sure that we have the right units. And so that was very tricky, but we do all that because we want to make sure that we fully understand what we're doing. So our answer is going to be A, closest thing to the answer. Not a hard problem, just a lot of unit conversions. So
I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, you're gonna wanna make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post. And if you wanna check out the next video, you can here.